Some animals have perfected the art of being black.
There's a really beautiful bird called superb bird of paradise that shows up on all the nature shows. When it does like its mating dance, it spreads out its wings into like a big black oval and then has like a blue smiley face on it. And the blue smiley face shows up really beautifully because the background is just like looking into a hole.
These butterfly species use contrast to attract mates too, and their scales can be 10 to 100 times blacker than charcoal. Deep ocean-dwelling fish use their ultra-black scales to hide from both predators and prey. Researchers at Duke University are studying these ultra-black creatures because it turns out humans have found uses for things that are super black too. Like coating the insides of telescopes so they can absorb enough sunlight to get us images like this. Our phones are also coated with black.
Your phone is an extremely black surface so that you can use it in the daytime. And this is also why if you leave an iPhone out in the sun, it gets so hot that it shuts down, because every single piece of light that hits that iPhone goes straight in.
So scientists are trying to understand how these animals are making themselves so black, so that maybe humans can learn from them. To make something ultra black, you need it to absorb light.
You not only have to absorb the light, you have to bounce it around, what we call scatter. You need to have a whole lot of scattering. Like if you remember back in the day, they would have like Velvet Elvis paintings. And the reason velvet is black is because it's got all these little black hairs that stick up. And as the light comes in, the light bounces around between the hairs. It can't just bounce back out. And every time it hits a little black hair, it loses a little bit more of itself. And so the fish and the butterflies that do this, they do this by creating structures that have a huge amount of light bouncing around in a very, very small space.
Here's what an ultra-black butterfly scale looks like under an electron microscope.
The butterflies do another structure that sort of sucks light down these holes and then traps them in like a little catacomb cave where it bounces around inside the cave and again can't find its way back out. And the neat thing about it is they're doing it in ways that are a lot more sturdy than what we do technologically.
Today, one of the blackest substances in existence is called Vantablack. It's made from microscopic structures called carbon nanotubes, which trap light. And they are very delicate.
So if you push down on a piece of Vantablack, it's no longer that black forever. But these fish and these butterflies, I mean, they exist in the world. The fish are swimming around, they're likely not bumping into anything, but they have to deal with, currents and movements of the body. And butterflies, they're running into things, they're getting rained on, they're living their entire life with these scales, and clearly they hold up, and they're still just as black.
That's why the team is studying ultra-black creatures. Alex created a mathematical model to figure out which parts of these elaborate structures matter most for absorbing light. That way, engineers can replicate it for materials we need to be super black. Because right now, those fragile carbon nanotubes are the best we've got.
The thing that animals are incredibly good at, we're very bad at. We're good at building things down to like about a millimeter or so in size, but it's really hard to build things that are much smaller than that. And cells are incredibly good. In fact, that's like where they like to build the most, is to build structures that are, in the thousandths of a millimeter kind of size, and they can build these just beautiful arrays that do absolute magic with light and so on.
Thanks y'all for watching this video, and if you want more where that came from, check out our channel, Sci and Sea. Stick around.